In this topic, I will explain you regarding the injection molding process. It is the plastic manufacturing process, plastic product manufacturing process or manufacturing technique. It is highly used in automobile industry to produce the fenders and bumpers. And for fenders and bumpers, to produce the fender and bumpers, high injection molding machine are used or high capacity injection molding machines are used. Uh, what happens in the injection molding or why it is called injection molding, I will explain you through the diagram, because if you have a pictorial view, you can easily understand what exactly happens in the process. The molten material, first I will explain you the configuration. There is one hydraulic cylinder actuator that is called the screw ram. Actually, screw will retract after the shot in backward direction through the cylinder, and there is one motor, and this screw will move forward or rotate in forward direction with the help of this motor. There are some heaters over the periphery of this barrel. Actually, from this point to this point, this whole injection unit is just like extrusion process or extrusion process setup. Instead of dies, there are mold will be used. Actually, mold have two parts. One is the movable and one is the stationary, right? And dies have a single. Sometimes dies have single cavity and single part. And mold, mostly mold have two parts. One is the stationary, one is the movable part. So from this end to the last, this is called the clamping unit. Like injection molding machine has two units: injection mold unit and the clamping unit. In injection unit, there is one hofer. The raw materials in the form of pellets or granule or powder will feed from the hofer into the barrel. This screw is the same as we have in the extrusion process: feed section, compression section, and metering section. And as a pressure builds up at the mold enters due to the polymer melt, here the screw begins to move backward under the pressure to predetermined distance. Like here, as you can see, this is the predetermined distance from the tip to the mold cavity, right? It is both the distance are predetermined. Like if you want to open the part at the end of the injection molding, this distance is predetermined by the machine manufacturer, and this distance after closing the mold, this injection distance will be predetermined or it is given by the machine manufacturer, right? um, the pellets and the granules will or normally are fed into the barrel from the hofer, and in the compression section this raw material will melt, and the screw will rotate and generate a pressure and the frictional force. Along with the pressure, the material will compress and move in the forward direction. In pumping section, here the material pressure is normally high, because the screw is continuously rotating and producing a pressure. There is one in a non-return valve. This non-return valve is used or is mounted near the tip of the screw. It prevents the metal or polymer melt flowing backward or flowing from back in backward direction. It will prevent the molten material. It could be possibility that if these both the mold or the mold parts are not close enough or not completely fit together, then there is a possibility that the mold or the molten material will come out, or the molten material will come out and move in backward direction. So this return valve is used to prevent the backward flow of molten material from mold cavity. And this is the clamping unit. Clamping unit is used to attach the two halves of the mold together, right? If you want to close the die during the injection process, this hydraulic actuator will move in forward direction, and it will use to attach the movable palaton or movable part of the mold to the stationary part of the mold. And after the short means when one part is produced, one shot is completed. This is called shot in injection molding technique. One part means one shot. For example, if you produce 10 parts or 10 shots in 10 minutes, means your flow rate is, or your production rate is, one shot per minute. That is your production rate. Like you are producing 10 shots in 10 minutes, like then your production rate is one shot per minute. So pellet or granule will flow into the barrel from the hofer. It will melt from the heating source inside the barrel. Screw will rotate and compress the polymer melt, and this screw will force the material to move forward. And in metering system, pressure will increase due to the friction between the wall of the barrel and due to the rotation of the screw. And this screw will move forward, and it is responsible to fill out the molten material into the mold cavity. It is responsible, or it will use this screw normally used to uh, inject the material into the mold cavity, right? It is rotating and injecting the molten material into the mold cavity. And after the injection, this screw will retract in the backward direction with the help of this hydraulic cylinder, with the help of his hydraulic cylinder, which is for a screw ramp. And as I've already told you, function of the non-return valve, I've already explained you. This is the step-by-step process of molding cycle. Molding cycle normally 10 to 30 seconds normally required. This is the production rate. And this production will also depend upon the material type, what kind of material we are using, and the material geometry. If you are using high or thicker material, then it will take longer time to cure or longer time to solidify, right? In this is the first step. Molten material is melting here inside the barrel. In second step, this screw is injecting the molten material inside the cavity. The force is applying to close the mold, and this force is applying from the screw. In the third step, solidification occur, right? And the screw will retract in the backward direction. In the last step, injector pins will use to open the mold and take out the mold or produce part from the mold cavity. This is the fourth part. For example, if you have a compound die, you can make same part with, like, you can produce this mold has four cavities of same part. Like you can produce same shape four times in one shot. Like you can produce four similar parts in one go, four shapes of four parts in one shot with the help of the compound die. But the compound die has some geometry. This geometry has some parts. One is spur, the other one is runner. This is branch runner. This is the main runner, and this is the branch runner. And this is the small part from where, which is attached to the part, and the branch runner is called gate. This is called gate. All the parts have different functions. Spur and runner and gate, all parts have different function. Through spur, for example, mold is in direction. This is a spur. Through through spur, the molten metal will flow will flow towards the runner here. Normally spur is attached between the runner, and through runner the molten material will distribute into different cavities. This From this main runner, the molten material will distribute in four cavities equally. And this gate is used to increase the sharing rate. And due to sharing rate, viscosity of the polar or the polymer melt will reduce and material is filled in the cavity properly. This gate will increase the shear rate. And due to shear rate, viscosity will decrease. And when the viscosity of material will decrease, then we can get proper filling of material into the cavity. Material into the cavity. The gate, I've already explained you the gate function, uh, and if you, I will now explain the function of partning line. There's one partning line, as you can see here. Partning line, where the mold open to remove the part. This is the partning line. This is the partning line. You can see this is the partning lines. This is the partning lines. And this partning lines are used where the material or where the mold open to remove this part. This is the part, and this partning line. This is the partning line. Like if you join the two molds together, the interface of the two molds is called partning line. The partning line is this is the connection point of two molds. Now I will again explain or clarify this function of slur. From the flur, the molten material will flow from barrel into the cavity through spur. This is the spur here, and through barrel. From barrel, material will flow into the spur, and from spur into the mold cavity. And from spur, it will not directly go into the mold cavity. There is one runner. There is one runner, and through this runner, as you can see, there is one runner, main runner, and main runner is connected to the branch runners. And branch inside, like branch runner is larger in diameter. This is the gate, and this is the main runner. And the gate is used to increase the shearing rate of the molten material or the polymer melt, which reduces the viscosity of the polar material, and the proper filling we will get. Due to proper filling, we can prevent our part from shrinkage and distortion. One more thing, you will have small holes in the mold. In the mold, I will show you here. This is the small holes in the mold, and this more these bores are called water channel, because water is circulating inside the mold to maintain the temperature of the mold. Because due to high temperature, degradation will occur, will change the mechanical properties of the mold. The mold can crack, or the porosity will create inside the part. Porosity means the small packets can create due to high temperature. Due to high temperature, we can get extra melting, and we don't require the extra melting. We require the proper and optimum melting during the injection molding. Due to injection molding, you can produce cups, containers, housings, uh, knobs, toys, so many things which are made up of plastic. You can use this injection molding process to produce these parts. Phone receivers, mobile covers, in fact, you can produce. But one important thing, the final product shape is exactly the same the exactly the same shape of mold cavity. The final product shape or the shape of the final product exactly the same shape of the mold cavity. Like mold cavity and the final product are similar in shape. Materials is nylon, which is the thermoplastic material. Polyphenylene is called. This is the thermosetting material. PVC is the poly uh, thermoplastic material. Then we have elastomers. Elastomers has high molecular weight. Polyester is also a thermoplastic material. So these materials can be used, or some more materials can be used during the injection molding, or we can produce different parts by using different polymers. Advantages: high production rate. For example, if you have 10 to second to 30 second to make one part, then we can produce a lot of part in 1 hour. Complex shapes can be produced, minimum wastage of material. Exactly in some time of in blow molding, you will study in next lecture. Blow molding, in blow molding, if you produce one bottle, after the production there is some extra material is attached under the bottle. You have to remove this extra material with the help of knife, or you can trim this material. So this is the material wastage. This factor comes in the material wastage. So in the injection molding, we have a minimum wastage of material. Disadvantage: high tooling and high tool and machine cost, high energy required to operate the injection molding. Exactly, if you want to produce the fenders and bumpers, as I've explained you, you need a high injection molding. High injection molding means it covers a lot of space in the production area. High tooling is required. Tooling means we need large molds, and the cost of the whole machine will increase because it will cost a lot of money. Like around, if you want to purchase a machine to produce a large part, uh, for example 10 square meter in area, then the cost of that machine which will produce large part, it was around or it will around $48,000 normally, which is a high cost for any industry. So this is all general information regarding the uh, injection molding. The next lecture or in the next topic, we will learn about the blow molding.